Welcome to Section 4.1, Part 1. This is the 34th session of the ISACA CISA exam prep series. In this session, we'll cover information technology components and the basics of networking. We'll work through several questions. What do technology operations actually involve? What are the common building blocks of those operations? How does the reference model for networking work? And how are local and wide area networks built and secured? Why does this matter beyond the exam? Because these components are the foundation everything else runs on. Picture a hospital network called Riverside. When its systems and connections run smoothly, care flows. When a switch fails or a link drops, patient records vanish from screens. Understanding how these pieces fit lets you spot the weak points. And service levels here trace straight back to business goals. So what do technology operations actually involve? They're about keeping systems and networks running reliably. That spans installing hardware and software, configuring systems, and managing the network. It includes backing up and restoring data, watching for security issues, and helping users. Done well, operations lift productivity and protect data integrity. They cut downtime and resolve issues fast. The professionals who run this know systems deeply. They keep things compliant and guard sensitive data from breaches. So what are the common building blocks? Start with infrastructure. That's the hardware and networking gear, plus the data centers that house servers. Those centers add climate control, backup power, and physical security. Next is the network itself, which connects everything and moves data. Then applications and software, the tools that run the business. Then system monitoring, which watches health and performance and catches issues early. Then backup and disaster recovery, which protect data and limit downtime. Then virtualization and cloud, which add flexibility and scale on demand. And finally, documentation and knowledge management, so the team can share what it knows. So how does the reference model for networking work? There's a standard model that describes how data moves. It splits communication into 7 layers. Each layer has one job and stays independent of the others. So you can upgrade one layer without disturbing the rest. Here's the clever part. Each layer talks to the matching layer on the far system as if connected directly. Think of it like 2 translators on a phone call. Each one speaks only to their counterpart, ignoring the wiring in between. So what does each layer do? Let's walk down the stack. The application layer gives programs a doorway to the network. The presentation layer formats the data, handling things like encryption and compression. The session layer opens, manages, and closes the conversation between systems. The transport layer delivers data reliably and confirms every packet arrives. The network layer handles addresses, routing, and forwarding. The data link layer moves data across one physical link and checks for errors. And the physical layer is the actual cables and signals. As data goes down the stack, each layer wraps it in a header. At the other end, the data climbs back up and each header is stripped away. Those concepts shape how real networks are designed. That includes local, wide, and metropolitan area networks and the public internet. So how is a local area network built? It covers a small area from one room to a few buildings. As it grows, careful planning of its layout gets more important. You track traffic, error rates, and response times to keep it healthy. The physical medium matters a great deal. Copper, twisted pair wiring is cheap and simple, but vulnerable to interference. Fiber optic carries light, with low loss, strong security, and no interference. For heavy traffic over long distances, fiber is what you reach for. Wireless radio sends data through the air with no cabling at all. Then there's topology, the shape of the network. The old options were bus, ring, and star. Today, only the star is used much in new construction. So what connects a local network together? A set of devices, each working at a different level. A repeater simply boosts a weak signal to extend the range. A bridge links two segments using hardware addresses, though it's largely outdated now. A switch does that job far more efficiently, with dedicated high-speed ports. A router connects separate networks and makes smart decisions using network addresses. Routers can become bottlenecks since they examine every packet. So place them carefully and lean on switches where you can. So what risks come with a local network? Quite a few. Unauthorized changes can damage data and program integrity. Remote connections can expose the network to outsiders. Viruses and worms can spread across it. An attacker might impersonate a legitimate user. Insiders can sniff traffic for useful details or spoof an address to hide. And without proper logging, none of it leaves a trail. So how do you secure a local network? With layered controls. Declare ownership of programs and files. Limit access to only what each person needs. Lock records to prevent two updates at once. Enforce strong sign-on rules for identities and passwords. Use switches to block unknown devices from connecting. And encrypt the local traffic. To really understand the network, an auditor documents who has privileged access, the topology, and who administers it. So what about a wide area network? It carries data across far-flung locations. Think across cities or even countries. It links separate local networks into one larger whole. Data can flow one way or both ways at once, and the lines connecting it can be either dedicated or switched. So let's bring it together. Technology operations keep systems running, built on a few core components. The reference model splits networking into 7 cooperating layers. Local networks use specific media, topologies, and devices, each with its own risks and controls. And wide area networks stitch those local networks together across distance. In the next part, we'll go deeper into wide area networking and how it all gets managed. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.